안녕하세요 여러분. 오늘은 미분방정식과 관계된 문제들을 풀어볼 예정입니다. 우리가 지금까지 공부한 미분방정식은 1기 미분방정식으로서 separable differential과 linear differential 두 종류가 있었습니다. 그리고 separable differential의 응용으로서 orthogonal trajectory를 계산하는 방법에 대해서 공부를 했었고, 또한 linear differential은 predator prey 시스템이라든가 logistic differential 등등을 풀이하는 데 사용될 수가 있겠습니다. 이번 시간에는 그 separable differential logistic 그리고 linear differential 그리고 orthogonal trajectory 등등등의 관련 문제들을 풀어볼 예정입니다. Today we will solve several problems of differential equations. We will deal with separable differential equation and linear differential equation. We may have some initial conditions. First, we assume that this holds, and we want to find the solution for this problem. It has an initial condition y0 equal to this problem can be considered as a differential equation of separable form because it can be so if y prime equal fx y, then this can be transformed to the following equation, and the right hand side is product of formulas with respect to x and y respectively. Then we can collect terms which have y and which have x respectively. So this becomes and by integrating both sides, we may have a solution for the given differential equation. This is a basic method to solve separable differential equation. And so this can be transformed to this form. So here is only the term of y, and here is the term of x. And then by integrating both sides, we can get solutions easily. So we have minus log 1 minus y is equal to log x squared plus 1 plus 6. Since y0 is 2, we can see that it must be 0. So the solution is given as so depending on the value of y, we have independent solutions. And then the next problem is also separable differentiation, but it's a little bit twisted. So we need some more technique to solve the following differential equation. This is a little bit noisy, and for the second problem, we consider xy prime is given as y plus x times e to the y over x. In this case, we want to find y. This is not a separable form of neither separable nor linear differential equation because we cannot separate, transform it in the form fx gy multiplied by. And so this is not a separable form, and the equation can be transformed as y prime minus 1 over x y is equal to e to y over x. Since here is y, we can see that it is not a linear. So we need some technique to transform this differential equation to a separable or linear differential equation. How? In mathematics, unification is simplicity, and unification is very important. So approach. Here, in simplicity, there is a substitution. If something is complicated or repeated, then it can be, we can consider substitution. Okay, so this is important in solving this problem. So at first, we transform the equation so that it has some unified property. So y prime is given as y over x plus e to the x over y. So you can see that this one and this one are repeated. Then we may substitute it. So we substitute y over x by t. Then we can see that y equals x multiplied by t, and y prime is you should be careful, t plus x t prime. T depends on x, so t may not consider that as a constant, and so by using the product rule for differentiation, we have certain equation. So in this problem, this part is important so that we can have separable differential equation in this problem. This part is the important part. So from this equation, we can see that we have equation dt over dx is equal to 1 over x e to the t. So we have a differential, separable differential equation, and you can solve the differential equation easily. E to the minus t dt is equal to x 1 over x dx, and by integrating both sides, we can solve it naturally. And so we can see that minus e to the negative t is equal to log x plus 3. And so value of 3. So we can see that by substituting t with y over x, so y can be given as minus x times log minus log x minus c, and x must be non-zero, and as c is a constant, we can regard it in this form. And so this is the solution for the given differential equation. And here we show that x is non-zero. And so in this problem, the given differential equation is neither separable nor linear, but by using some suitable substitution, we can transform it as a separable differential equation. In the following problem, we also consider a separable differential equation. dy over dt is given as 1 plus t square plus y square plus t square y square, and assume that y0 is 1. Then we want to find the solution of the given differential equation. The right-hand side can be factorized as a product of the following: 1 plus t square, 1 plus y square. So this is a formula of t, and this is a formula of y, and so we can see that this is a separable differential equation. And by collecting terms with the variable y, we have the form. And by integrating both sides, we may get solution of this differential equation. So you can see that arctangent y becomes t plus t cubed over 3 plus c. Since y0 is 1, we can see that c is pi over 4, and so we get a solution as following. Okay. So you should be careful that this can be the first two lines are important in solving this problem. If you can transform the given differential equation as a separable differential equation, then we can solve naturally the problem. And the following problem is also a differential equation which is neither separable nor linear, but it can be transformed as separable differential equation. We want to solve this differential equation. At first, you may think that this is not a differential equation of order 1 because here is y double prime. So this is actually a differential equation of order 2. we have not studied how to solve differential equation of order 2, but we can transform it as a problem of separable differential equation of order 1 as following. Because you should be careful that this can be represented as if something is repeated. So mathematics writes unified or something. So you can, if you represent this one as the differentiation of y prime, then you can see that this and this are repeated, and so it can be substituted. So we can get an idea to solve the problem. So this is the process of getting idea to solve the problem. So let's just solve the problem. Let t is given as dy over dx, then we can see that from the given condition dt over dx becomes root 1 plus t squared, and you can see that this is a separable differential equation. So by collecting terms which have variable t and x separately, we can have equation of this form, and by integrating both sides, we can have arc hyperbolic sine x sine t must be equal to x plus c, and so t is equal to hyperbolic sine x plus c. So by substituting t with the initial one, dy over dx, then this becomes also a separable differential equation, and so by integrating dy, you can see that this equation holds, and so y must be the integration of this part. Since the integration of a hyperbolic function is hyperbolic cosine, and this becomes of this form. So c and c prime are independent constants. And let's consider another differential equation. The next problem. Let's start with the equation given as 1 plus x squared y prime minus x plus 1y is equal to 2, and this is actually a linear differential equation, and by using the integrating factor you may solve this problem, but in this problem you can solve this problem by using some technique, by using the method of solving separable differential equation. So let's try to solve this differential equation with the method of solving separable differential equation. At first, we want to find polynomial solution. double star the equation 1 plus x squared y prime minus x plus 1y is equal to 0. So by replacing 2 with number 0, you can get double star. And show that we want to show that y is the solution of star. If and only if C, which is given as y minus y0, which is find the first step, is a solution double star. And the third problem, we want to by using the result obtained from the first problem and the second problem, we may solve the solution for star, and we want to find a solution with the initial condition given as y0 equal 1. To solve the first problem, we try to find a polynomial satisfying the given differential equation. So the simplest, if you consider the simplest polynomial, which is a constant, then you may see that there is no solution of a constant. But if you consider a linear equation, and then 1 plus x squared 0 minus x plus 1 c must be equal to, so we may get a contradiction, and so try y to be a linear equation to be a as the solution. The second trial, we want to check whether a linear equation is a solution of the given differential equation. Then from the given equation, you can see that 1 plus x squared a minus x plus 1 ax plus b must be equal to, and so you can see that a equal 1 and b equal minus 1. So we may take y0x to be x minus 1. Actually, there can be many solutions for the first problem. So this is not the unique solution for the first problem. Okay. And then the second problem, we want to show that y the solution of a star if and only if G is the solution of a double star. And so it's very simple, just following the definition. So if y is the solution of star, then we can see that y satisfies the condition, the given condition, y prime minus x plus 1 y is equal to 0. And if g equal y minus y, y0, then 1 plus x square y0 prime minus x plus 1 y0 is equal to 2. So by using this part, we can see that 1 plus x square y minus y0 prime minus x plus 1 y minus y0 must be equal to minus 2. Sorry, solution was that, and this must be equal to 2. I made a mistake, and so this is equal to 0. And so you can see that by putting g to be y minus y0, this becomes g prime minus x plus 1, c is equal to 0. And so g is the solution of okay. So in this way, we can prove this part. And then the third problem, we want to solve start by using 1 and 2. So we have already taken 2y0 as x minus 1. So if we solve double star, then we may solve star. So let's try to solve the differential equation given as double star. Double star is a separable differential equation, or it's a kind of a linear differential equation. Anyway, we can find that 1 plus x square g prime minus x, we consider this equation, then 1 plus x square, that's right. And so do not this part. And so we have and this can be given as so in this way, you can, I want to omit some process. Anyway, you may solve the equation y4 y0 plus c. try. X minus 1 plus a to the where a is some constant, and on the post problem by using if y0 is 1, then you can see that a equal to, and so we have a solution given as in this form. Okay. 에어컨이 안 틀어져서 약간 덥습니다. 촬영하는데. In the next problem, we want to find an orthogonal trajectory for a given collection of curves. So k be any constant, and so it can be the fraction of curves can be drawn in this form. If k is a negative number, then the fraction of curves can be drawn in this form, and we want to find an orthogonal trajectory for this collection of curves. So the starting point is very important. That x and y, the point C is a point on y equal into the kx. And the orthogonal trajectory if here is an orthogonal trajectory, then the tangent line, at this point for these two curves, it must be orthogonal. So this part is important in solving this problem, but you should be careful that something can. This means the derivative of the function given at here. So dy over dx must be equal to k times e to the k times of x. At this step, it's very important that y is e to the kx. We should remove k. So k must be equal to log y. Y must be positive, and so we should remove k by using this equation. To remove k, problem is remove k. To remove k, we should find what is k. If you know the opponent, the enemy in a game, then you can win the game easily. So if you want to remove k, then you should know what is k. So from this equation, you can see that k is log y over x, and so this can be given as you should be careful that here there must be no terms of k. K should not appear right here. Some students want to solve the problem just by using this equation, not using this equation, then in most cases it failed in examination. So this part is very, very important. Basically, a problem of orthogonal trajectory is very easy, but in the midterm examination, many students failed to solve a problem of orthogonal trajectory because they don't express dy over dx in terms of just x and y. So you should be careful that there is no term of k. And then then we solve the tangent line, the slope of a tangent line at here must be, slope should be, because since the two lines are orthogonal, slope must be minus x over y log y. Okay, the slope means dy over dx. So we solve the equation dy over dx is equal to minus x over y times log y. This is a separable differential equation, right? And by collecting terms of y, we have equal minus the integration of x. And so you can get the solution by using integration by part. You can see that this part becomes by multiplying 2 to the left side and right side, we can see that 4, not 2, but 4. We multiply 4 both sides, we can get a solution with this form. So it's a little bit complicated one. From now on, so far we have studied how to solve a separable differential equation, and we should study how to solve linear differential